Welcome to MRL. In this learning session, we will learn Introduction to Linear Polynomials, a chapter of Ganitha Manjari, a 9th standard NCERT textbook. So let us begin the first part of this chapter. Now the first word here is constant. A quantity which has a fixed value is called a constant. For example, 5 is a constant because it has a fixed value. Numerals are constants, remember that. Now variable, second word is variable. A quantity which does not have a fixed value is called a variable. The letters x, y, z, the small letters represent variables. Rather, small letters in English language, they are used to represent variables. Therefore, x is a variable because x can take any value. So literals are variables. Now what is an algebraic term? An algebraic term is a variable or a product of a variable and a constant with any sign. For example, x is a variable. It is because it's a literal that is a letter. X square is also x square is also an algebraic term. X is an algebraic term. X square is an algebraic term with power 2, and 2x is also an algebraic term where x is a variable and 2 is a constant, and it's a product of a constant and a variable. So therefore, algebraic terms can be a product of constant and variable with any sign, with any power, and it can be a quotient. Remember that. Now the next important word is algebraic expression. The sum of algebraic terms is known as algebraic expression. That means when we add or subtract two or more algebraic terms, then it is an algebraic expression. Now we have to know how to identify the terms, variables and the coefficients of a given algebraic expression. Here I have taken an example that 5x square minus 3x plus 7 is an algebraic expression because there are terms added and subtracted in that, and here 5x square minus 3x and plus 7 are the three terms of the given algebraic expression. X is the variable, 5 is the coefficient of x square, minus 3 is the coefficient of x, and 7 is a constant. So we have to know to identify the terms, variables and coefficients in an algebraic expression. Now algebraic expressions can be in one variable or in two variables. Now in one variable there is only one variable, that is x. So if you look at this example, 3x square plus 2x minus 7 is an algebraic expression and there is only one variable, and that is x. We can also have algebraic expression with two variables. 4x plus 5y plus 3 is an algebraic expression with two variables because there are two variables x and y in it. Remember that. Now coming to the next important term, that is polynomial. A polynomial is an algebraic expression in which the powers of the variables are whole numbers or positive integers. Please understand this. A polynomial is an algebraic expression in which the powers of the variables are whole numbers or positive integers. Let us take some examples. X plus 2 is a polynomial because the power of x is a whole number or a positive integer, that is 1. Similarly, x plus y plus 3 is also a polynomial because the power of x and y are 1 and 1, that is whole numbers. X square plus 3x minus 7 is also a polynomial because the power of x is 2 and the power of x is 1, again whole numbers or positive integers. Please remember, if the powers are not whole numbers or positive integers, then they are not polynomials. Please remember that. Now there are different types of polynomials, and the types of polynomials are on the basis of number of terms. Now if there is only one term, then we call it as a monomial. A monomial is a polynomial of one term. X is a monomial, 2x is a monomial, minus 3x is also a monomial because there is only one term. Binomial is a polynomial of two terms because there are two terms here, x plus 2, x is one term, 2 is another term. Similarly, x square plus x is also a binomial. Then we have a trinomial in which a polynomial has three terms. We have three terms here in the example, x square plus 2x plus 2, that is x square is one term, 2x is another term, and 2 is another third term, and therefore it is a trinomial. So please remember that. Now univariate polynomial, it's a new word. a polynomial with one variable, please understand, a polynomial with one variable is a univariate polynomial. Uni means one, variable, so variate, so univariate polynomial, a polynomial with one variable. This is a monomial with one variable, this is a binomial with one variable, and this is a trinomial with one variable x. Now polynomial of two variables, there can be a polynomial with two variables also. This is a polynomial with two variables x and y, this is also a polynomial with two variables x and y, but it is a trinomial and this is a binomial. Now let us go to the next important term, that is terms of a polynomial. Now terms of a polynomial is again same like algebraic expression. Now if you take a polynomial ax square plus bx plus c, then it is a trinomial. It is a trinomial. Ax square is one term, bx is another term, c is another term. So we have three terms here, therefore it is a trinomial, and a is a coefficient of x square, b is the coefficient of x, c is a constant, and x is the variable. So that is how we identify the terms of a polynomial. Now the next important word is constant polynomial. The integers are constant polynomials. Any integer you take, that is a constant polynomial. For example, 5 is a constant polynomial because we can express 5 as 5 into x raised to 0. Therefore, 5 itself is a polynomial, although x is not visible to us, but x raised to 0 is 1, and therefore 5 into 1 becomes 5, and therefore 5 is a constant polynomial. Now we also have a zero polynomial. A constant polynomial of 0 is a zero polynomial. For example, 0 is a zero polynomial because 0 can be expressed as 0 into x raised to 0, x raised to 0 is 1, 0 into 1 is 0, and therefore it's a zero polynomial. Now representation of a polynomial. A polynomial can be represented by symbolically as p of x, q of x, r of x. That means p of x means it is a polynomial in variable x. Therefore I can write any polynomial as p of x is equal to x square plus 2x plus 2. It means that it's a polynomial in variable x. So please remember that. Now the next and very important word is, or term is, degree of a polynomial. The highest power of the variable in a polynomial is called degree of the polynomial. Try to understand this. The highest power of the variable in a polynomial is called degree of the polynomial. Let us understand. X plus 2 is a polynomial, it's a binomial. Power of x is 1, therefore its degree is 1. X square plus 3x plus 2 is also a polynomial, a trinomial. The highest power is 2, and therefore its degree is 2. So please remember that x plus 2 is a first degree polynomial, x square plus 3x plus 2 is a second degree polynomial. Now degree of a constant polynomial, again very interesting here. We know that phi is equal to phi into x raised to 0. What is the power of x here? 0. Therefore the degree of a constant polynomial is 0. So please remember that degree of a constant polynomial is 0. Now again we can classify the polynomials on the basis of degree. Earlier we had classified on the basis of number of terms. We can also classify them on the basis of degree. Now a linear polynomial, a first degree polynomial or a polynomial of degree 1 is called a linear polynomial. If you look at this example, x plus 2 is a linear polynomial because it is a first degree polynomial or a polynomial of degree 1. It's a binomial but the degree is 1, therefore it's a linear polynomial. Then we have a quadratic polynomial. A polynomial of degree 2 is called quadratic polynomial. If you look at this example, x square plus 2x minus 8 is a trinomial. The highest power is 2, its degree is 2, therefore it's a quadratic polynomial. Then cubic polynomial, a polynomial of degree 3, that is x cube plus 3x square minus 2x plus 1 is the example of degree 3, and therefore it's a cubic polynomial. So that is how we classify the polynomials on the basis of degree. Now coming to the next term, linear polynomial in one variable. Linear polynomial in one variable. That means a polynomial of degree 1 with one variable is called linear polynomial in one variable. For example, if you take this example 3x minus 2, it's a polynomial, it's a first degree polynomial, and it has got only one variable, therefore it's a linear polynomial in one variable. Please remember that. Now the general form of a linear polynomial in one variable. The general form is ax plus b. That is p of x is equal to ax plus b is the general form of a linear polynomial in one variable, where x is the variable, a is the coefficient of x, and b is a constant. Please remember that. Now linear polynomial in two variables. A polynomial of degree 1 with two variables is known as a linear polynomial in two variables. If you look at the example x plus y, there are two variables here, so it is a polynomial in two variables. 2x minus y, there are two variables here, again it's a polynomial in two variables, and the variables are x and y. The general form of a linear polynomial in two variables is ax plus by plus c, where ax, by, c are the terms. It is a trinomial. A is the coefficient of x, b is the coefficient of y, and c is a constant. And the important part is, or important thing what you have to remember is, the degree of this trinomial here is degree 1, because the power of x is 1, the power of y is also 1, so it is a linear polynomial in two variables. Remember that. Now sometimes we are given a polynomial and we are asked to find the value of the polynomial for a given value of the variable. Now let us understand that a polynomial has a value for every value of the variable. So you are given the values of the variable, we have to find the value of the polynomial. For example, if you are given a polynomial p of x is equal to 2x plus 3 and you are asked to find the value of this polynomial when x is equal to 4, just put the value of x, that is 4, in this polynomial. So it will be 2 into 4 plus 3, 8 plus 3, that is 11. Therefore the value of this polynomial is 11 when the value of x is 4. So like that we can have different values of the given polynomial for different values of the x. That is what is called as the value of the polynomial. Now to find the value of the polynomial for a given x value, substitute the value of x in the polynomial and simplify it. That is exactly what is the procedure I followed here. It is an input-output process. Very interesting it is. It is also called as finding the value of a polynomial is also called as input-output process, because what you are giving an input is the value of x and what you are getting output is the value of the polynomial. And here you have to remember the polynomial here is a function of x. The polynomial p of x is a function of x, because the value of the polynomial depends on the value of x. Therefore it is a function of x, rather the value of px depends on the value of x, that is the variable x. Now the last important point of discussion in this particular part is linear equation. We already know what is a linear polynomial. We know that px is equal to ax plus b is a linear polynomial. But now if a linear polynomial is equated to a constant or equated to 0, it becomes a linear equation. And we all know what is an equation. An equation is basically a statement which shows equality between two quantities. There is LHS and RHS and equality sign in that. So also in a linear equation there is a linear polynomial in it. There is LHS, there is RHS, there is equal to sign. Only thing is that the RHS will be generally a constant or 0. So therefore a polynomial equation of first degree is a linear equation. A linear equation has a linear polynomial equated to a constant or 0. For example, x plus 5 equal to 0 is a linear equation in one variable, and 3x plus 2y plus 7 equal to 0 is a linear equation in two variables. So these are some important basics which you have to learn, remember and note down in a book for your future reference. Okay, so let us proceed with the second part of study of this particular chapter, and then we'll see what further we have to learn for understanding this chapter of linear polynomials. Okay, thank you.